In this video clip, I'm going to demonstrate how to create a sequence of models, regression models, with a different level of what degree of model complexity. So basically, here we are selecting useful inputs. So let's take a look. So from here, this is where we were, and we're gonna create a we're not creating it, we're actually making some changes in our regression node. Select regression node and look at this properties panel window and look for where the selection model is. So if I scroll down a little bit, so under model selection heading, we have selection model. None was selected by default, but we're gonna change it to stepwise. Remember this? I mean, when we discussed in class, there are three ways by which you can select a model. One is forward selection. So you're creating a sequence of models with increasing model complexity. So beginning with a model with only one input, the question is which input should enter? I mean, which input should be the only single input to be entered? And then you move to the model with two inputs and so on. That is forward selection method. Backward selection method, you begin with a model with entire set of inputs. Let them enter to the model, and then we exclude one by one. Stepwise is the hybrid of the two. So you switch back and forth between forward and backward. The methods. So selection is the one we're gonna use in this example. And then with that change, let us run the model. So stepwise, at a given step one, we look for which input to enter. And once we select the most informative input from our input list, and we look for which one to exclude, I mean the most irrelevant one. And then at the next step, again, you look for which input to enter, and look at the inputs on the model and which one, and look for which one to kick out. So you basically switch back and forth these two steps. The input entry and input exit. So please refer to the lecture note and the tutorial note. It has detailed description how it works. In this video clip, I just want to demonstrate how we execute the stepwise selection method. And to do that, this is the only change. We change selection model from none to stepwise mode. Okay, it looks like it's completed. Select results window. And I'm gonna maximize the output window we have. And from line, take a look, 79. So this is step 0. So we only have an intercept, or a bias, depending upon how you call it, entered into the model, right? None of input variables we have have entered yet. And then step 1, like I said, E-miner searched through the entire input list to look for which input should enter at this moment. It turns out get count 36 variable carries the most information. That's the most informative one. Help us maximally isolate donors from non-donors and non-donors from donors, and that's the reason why it was selected and enter the model. And if you look at line 199, it's displayed odds ratio estimate, which we will interpret later on. Basically, when gift count 36 increases or changes by 1, this is what happens on person's odds ratio. That odds ratio increases by a factor of 1.133. In other words, odds ratio increases by 13% with respect to 1 unit increase in gift count 36. And at the second stage, new variable, gift time last, enter the model. But notice that non-input has left. Right? So remember, we are using stepwise regression method. So it actually scanned through all the inputs entered and look for which one to exclude, but non-inputs were excluded. So that's what happened. And step 2, new input entered, and scroll down all the way to line 366. Again, this input entered. So if we scroll all the way down to line number 851, this is a summary of stepwise selection. It shows, which input entered at a given step. Interestingly, none of these they left. They all, once they entered the model, they remained. So that's what happened in this particular example. And if you look at the last column, in terms of p-value, all of them, their corresponding p-values less than 5%, less than 0.05. So every single input in this, 8 inputs just have been entered, they carry statistical significance. So each of them is significantly important with respect to predicting our target outcome. That's the reason why they enter the model. So out of 45 inputs, now we only allowed for these 8 by using stepwise selection method. And let me restore this output window and look at fit statistics window we have. If I highlight the last row, misclassification rates. Remember, when we look at the fit statistics window in our first regression results, the difference between these two values was as much as like 0.02, right? When we used entire set of inputs. But now, selecting only 8 inputs, it helps us to sort of reduce the gap or the difference between the two. So in other words, by running a stepwise selection method, we were able to alleviate the concern for model overfitting. So that's it, and let me stop here.